a course. Yeah, that is one thing, but this is a daily lead code problem. So yeah, 6923 daily lead code problem of today, lead code. So yeah, the problem is medium level, and I believe it. Yes, I believe it. And what you have been given is a linked list. What you need to return is a vector of linked list. What you need to do is to split the given linked list into some number of pieces. That number is given. Okay, how can you split a linked list of size 3 into pieces or 5 pieces? The answer is yeah. First of all, like this is the answer. So yeah, so it's possible, and this is the answer. Like you'll say 1, 2, 3, and then yeah, empty, empty. So this is your 5 link list. So how is it getting created? The rules are stated in the problem of partitioning. Okay, or splitting. The rules are that okay, you will split, and any of the two linked lists that you pick after like splitting, completed splitting, should not differ by more than one length. Okay, yeah, because we want equal splitting, right? Okay, but is equal splitting always possible? Like really, not always. 1 to 3 cannot be split into 5 parts. It can be split into like 5 equal parts. Yeah, so you can have 1, 2, 3 as a single thing, and then 2 are just empty. So yeah, how to approach this, how to get this, and a good example would be when the length is big and you need to do, let's say k equal to 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and my opinion would be just it is better to keep like the link list which is exceeding the length by 1 unit if there is a case. And when it will be a case, let me put it straightforward. So your length is something, and you have been given k. If your length perfectly divides your k, right, then you will not be having any disparity in size. But if not, then you will be having how many disparities? A length modulo k. So you'll find out what is the modulo, right? And those many linked list will be having a size one greater than the remaining linked list. Now how to determine those linked lists? So that's what I said about that, keep them on the first position. So now what you need to do is actually is a traversal. Let us go while h c out h size, not h size but h val. Yeah, let's just print h val, and h is equal to h next. Okay, is it like really what you need to do? Yeah. Okay, you will think like what am I doing? Like this is not at all related to anything. But yeah, just 2 line of changes and this is the whole code. Yeah, but that's what you need to do, right? You have to find those 2 line of changes, and you feel it is. You feel it is why? Because at least I'm doing a traversal, right? I'm moving forward and I'm having all the pointers, but what I need to do is to have a separate. Okay, so first of all, how I will separate it? Okay, I will not go from 1 to 2 to 3. What can be done? Okay, let me show you one thing. If someone would just told you to separate it, okay, in the basis of like let's have that. Okay, first, yeah. So like in the process of building a solution step by step, intermediate step can be that okay, you do something like this: r dot pushback h. Okay, you pushed, and h is equal to h connects. Do you think this is correct? First of all, yeah, you would know that this is not correct. What I'm doing is that okay, you would push r dot push back h. So first linked list you will say 1 2 3, second list 2 3, third list only 3, only last is here correct, right? But even sometimes the last is not correct. Okay, so this is the is it answer, but you got like what you got yeah, some number of splittings, but that's not whatever you are looking for, right? That's not what at all what you was looking for. Okay, but this is the thing. When you want to start something, when you want to start a list at a particular point, right? Do you want this or not? You want this, yes. You want a list to start at 3. You want a list to start at 9 because initial list is not starting at 8. You want the list, one of the lists to start at 8 and go till 10. That's also the thing. Over here, I just care about starting point, not cared about the ending point. So it took all and all till end, right? So in this case, what we have to take care like 8, 9, 10. Okay. And what about previous thing? So it's 5. From 5, I'm not going till 10. I'm not going like all, I'm going only three. So that's what you need to make sure, that pushback h and will I say h connects equal to null. Okay, this is what the something which I was saying, that this is a middle step. When you say okay, push one, okay, now one is sorted. Now one connects equal to null. Okay, what do you mean? It means that okay, one is a separate list now, and that's pushed into R. And I disrupted my list by saying that okay, one is not now part of this, two is there. Okay, so h next equal to null. But how do I get to two? H equal to h connects equal to null, right? So if I do something like this, or you say that that's wrong because h connects equal to null and you cannot, you should not assign, you have to go to 2. So let's try this. H equal to h connects, now you are on 2, h connects equal to null. Now if you say null, you are breaking this 2 3. I wanted to break this 1 to h. So how do you do that exactly? You store temporary pointers. You store tp equal to h, yeah man, like something like this. tp equal to h equal to h connects, tp connects equal to null, something like that. Yep. TP connects equal to null, edge is equal to edge connects while edge exists. Your this is going, and this TP is helping you a bit. Let's see how this goes now. This initializes with anything. Yeah, so that's what you wanted. Did you wanted this like all separated? But yeah, there is a way to separate all. So that's why I said that only one or two line changes, and that's all. Like remaining things, like yeah. And one of the uh major change is that like now I separated the things, right? I separated the complete list. But now what's the next change? What is the next step? The next step is not like do like this, like split all. Like we don't need to do that. We only need to split like a chunk. Okay, so a chunk, what I mean by that in this case, like 1 2 3 4. So if I show you the second test case, you know, you got the idea what is happening. It will just split everything. So that's not at all what we want. Like in the second test case, we want something like 1 2 3 4 to be together. Okay, how do you do that then? Hmm. I say that okay, you are doing a good work, like you are splitting it, everything. You don't need to do that much work. Okay, let's reduce your work. And from 1 to 4, you don't need to do work, but start doing work for 4 to 5, and then you don't need to do work. Okay, when I say that you don't need to do work, something like I'm saying while k minus minus, something like yeah, something like sz minus minus h is equal to h next. That's what I'm saying. What does this mean? H equal to H connects. Okay, what does this mean? And also, how does it affect your TP? That is a major thing first. Because your TP was initialized to H pointer, like with the one. Still, if you do TP connects equal to none, so you will be separating one. So first thing is first that TP is not H, but TP is now H. Okay, now H, whatever it is now H. First thing first. So you got your h, then you said okay, don't do work for some amount of time, this is sz is that amount of time, and then you just move freely, like yeah, just move, and now you're on the something when you need to do work. You are on 4, you need to do work. What is the work? That okay, first store 4. Okay, I stored tp equal to the node of 4, and the main thing is tp next equal to null. So you did the work, but to go and start the work again from 5, you need the pointer to that. So h equal to h connects. Yeah, so h was your 4, h equal to now 5, tp connects equal to null. That's sorted. Just you need to make sure that sz should be something like okay, 1 was my thing. So one unit you will move to 2. Second thing, you are on 3. Third thing, you are on 4. So it should go only three places, right? So is it 3 equal to k? No, that's not at all the thing. But yeah, the 3 is coming from the logic that okay, you need to split it into 4 3 3. That is the split, how it will splitting, because the total length is 10, I feel. So 10 divided by 3 is equal to 3, and mod equal to 1. So I said that give mod to the first one. So now I'm like taking it very fast. But this logic I have already discussed. Like okay, like you have to understand why this sz. What is this sz? This is the size of a one partition, one portion. What is the size of one portion? Do you know? I said if that happens, like if it perfectly divides, then the size is equal to len upon k. That's fine. What if it not? What do you mean if not? If not means you have a remainder. Remainder is equal to len mod k. Now How many partitions? Partitions, I knew like number of partitions is fine. But yeah, what is the length of partition? Again, length divided by k for a general partition. But for a special partition, what is a special partition? What is a general partition? Can you tell? Like, yeah, I told you that when there is some remainder, like in this case, there is a remainder. This three are not actual divisor. Divisor is zero or whatever, like quotient or whatever. Like the 5, 3 upon 5 is zero. We know that. Like length was 3, k was 5, so 3 upon 5 is equal to 0. So I'm saying that partition length should be 0. Yeah, that's fine. That is a general thing. Okay, that's why these two are 0 length. What is the special or what is the not general thing? That is the remainder. For the remainder equal to 3, so 3 list, I'm saying 3 list. Which 3 list? You can choose any, but I'm saying it's good to have initial 3 list. Okay, let's have initial 3 list. And what will be their length? Their length will be whatever the normal length we are calling. Let's say this is equal to normal, so normal equal to this, so your the length for the special is equal to normal plus 1. Yeah, you know that, man. I think I'm exaggerating it a bit, but yeah, that's how like how remainder system works and how divisor system works. That okay, it's kind of like you don't need to do extra thing. Like one way I could have done is like 1 2 3 fill it up here and then do everything like empty 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 empty. This is one partitioning of size 5, but the condition was that ki you cannot have something like size difference of 1 at yeah greater than 1. So this is the thing. Now this is the thing. And so sz is a dynamic quantity. That's an important thing to note. Now how do you get that dynamic quantity? Yeah, it's simple. We work with dynamic quantities like id. We can do id. So how we can say as if id is greater than something. Something, what is the something? The something is very easy to understand, or like you can get is a remainder, then my sz minus minus. Okay, okay, do you do every time sz minus minus? That's a very wrong thing, right? Okay, then what to go, what to do, what to do? Let's say one thing what you can do is that only if it is equal to remainder, then I do z minus minus. Yeah, this looks more promising now. Okay, but yeah, there are a couple of ways. Like you can have size 1, size 2 for special thing, general thing. And if id is lesser than that, then size 1. If id is greater than that or equal to that, then size 2. You can go by that. Because like I'm saying zero indexing. So this is 0, 1, 2, and 3. So for 3, which was your remainder, you are having size 0. So that's what this is coming for. That's how this id, if you start this id equal to 1, then instead of remainder you should go for remainder plus 1. But yeah, now I think it's fine. And sz minus minus and sz. What is it? Sz is very simple thing. It's a very simple thing. I'm telling you, it's length by k. But you don't know what is length. That's the main part, right? Int length, so not needed as such, but len equal to 0. And what can be done is that while tp exists, l plus plus and tp equal to tp next. Okay, what is this tp, what is this l? You know it, like what I'm doing. Everyone knows how to get the length of the linked list, right? That's not something which we are doing. So yeah, that's why I said every question has a part where you have to be logical and where you have to be like, yeah, memorized person. um Not like that, but yeah, where you have to be really fast with it. Let me put it in that way. Like you have to be really fast with these kind of things. And should be fine, man. If it is fine, so HL plus plus TB. And yeah, let's go with this. Now again, one thing is that length by k. What was my length by k? Length by k was 0. That was 1. So you will do for 1. Okay, 1 time. Let's go to h equal to h next. Let's go. Yeah, let's go. Okay, okay. But then it would be 0, right? So length by k plus 1. Are you saying something like that? Yes, yes. Remainder can be 0. If it is 0, then I'll do minus minus. And even if it cannot be 0, size cannot be 0. Size will be something like size can be 0, obviously. But then if size is 0, what to do? Yeah, that is also the thing. We push back h. While size is 0, this will not run. TP, I don't know what you will do then. Like, why do you don't know? If TP equal to h, your TP will be h. your h equal to h next. H next does not exist. Yeah, that's the main thing. H next does not exist. So you will only do it while h exists and h can have something. Now this is the main part with this. Like every portion, as I said, has some part. This is the part where you have to be like really working with edge cases, like really working with edge cases. TP was not defined here. Where so TP equal to edge. TP was the man. Redefinition of TP at all. L. So length is equal to L. This is the main part that should work. LH is not equal to none. REM. What is REM? Okay, now one part is that length would not come out good. I don't know why. Or it. Let's see. What is length coming? Just commented everything, but return R is needed. Okay, if length is not coming like this, okay, it is coming. It is giving me 10. Fucking okay. 10. So divide by 3. Okay, then modulo 3, we got 1. And for first time, you will have your L by 3, 3 plus 1, 4, and you will have pushed it and you will run for 4 times and it should exist. It's next, run till then, and then you got TP equal to H. Okay, do you run for 4 times? Really? Actually, no. Yeah, so you should have it like that. Run only 3 times because if you do 3 skipping, you are on the 4th thing. That is one thing, okay. And while pushing, I was like always saying that you can have H val just to know what you are pushing. Yeah, it's giving runtime, but because of accessing null pointer. So you got 1, okay. Then you got 5, okay. That is fine, yeah. Now then you got something, but why you don't got something? When you pushed 5, ID is equal to REM. Is that so? I mean, like, yeah, yeah. Now ID is REM. Who's plusing ID? No, and then equal to REM, then minus. Instead minus minus. So yeah, that is also one thing, yeah. When you say z equal to 1, you think that it is size equal to 1. Actually, no. It's the number of skips. Yeah. So size is greater than that. Oh, because when you skip, let's say 1, 2, 3, 4 is your list. You skip 1 to 2, you skipped only one thing, but you got length equal to 2. 1 to 2 to 3, 2 skips you made and length equal to 3 now. What man? Size minus minus while size minus minus and h is equal to h next. Okay. This is very wrong thing, man. Why? How can you do size minus minus? And like, are you crazy? Temporary size. Yeah, so that's what I said, that instead of using while for I in this to this, and h exist. Important. Oh, now you got something. All right. 1, 2, 3. Okay. Okay. So if h is not something, what if h is equal to null? Okay. Now you don't need h equal to null. Or how can you determine that? Determine like how many times did you rain? You rain like id times. Okay, you can see out id also as well. Id. This will be a see out. I'm not printing any number, but id is equal to, oh man, what is this? 3 3 10. Acha, I am also printing size. Forget about size. So you got 3 3 10 3. So that you need to match with your thing. So but what I'm saying, just for int I equal to starts from id, I is less than your k, r dot push back null. This is what you will do, just to make sure that, yeah, from id to that you have those things. Now I even deleted that C out, so it should not affect any runtime. And yeah, as you can see, this is today's daily lead code problem. I would say it's a nice problem combination of some things, but yeah, again, straightforward implementation. Okay guys, bye.